All right. So, good evening to all the grade 12 students. Welcome to one more session of your WC. So, as a part of our revision, we have been, I think it's almost 5 days that we have started the series. So, to all the new students who join me for the first time, new students, welcome to the channel. How are you all doing? So, new students, welcome with a wonderful smile from my end. Yes, for all you old students who are there with me since long, I have to tell you my gratitude to all of you students. My gratitude. Thank you so much for staying connected. All right. Today we are going to start with the day 6 series. This is what we are going to do today. As you all know, in this particular series, I'm going to cover 10 chapters. Yes, students, completely 10 chapters is what is there for your boards. So I'm going to cover in that 10 chapters multiple choice questions. Very short answers, short answers. In this also you have, this is 1 mark means here you have 2 mark and 3 mark. When I'm doing short answers, I'll also be doing long answer questions, students, long questions, which will include 5 marks. Assertion and reasoning, content-based type, analogy type, and important board questions. So till the important board questions, it will be till the latest sample paper. Okay. So from all latest paper, this one to latest sample paper is what I'm going to discuss. Everything will be there in this series. Okay. All in one series. All right. So now, as you all know, in this particular chapter, which chapter did I start? I have started with your HaloAlkanes, correct, right? So this HaloAlkanes chapter, yesterday I have sent you 100 MCQs. 100 MCQs is what I have sent you. So this 100 MCQs, it will cover every line of your book. So please go through that. So today I'm going to take up the next part, that is 1 page revisions. In this video I'm going to teach you 1 page revisions, and 1 page completely, the whole chapter will be in the 1 page revision. I'm also going to take up the short answer, that is very short answer questions. Then gradually I'll be doing more and more. Let's start. So when I go with the HaloAlkanes and HaloArenes, this is a classification, that is your 1 page revisions. So this is my handwritten, so everything will cover in this 1 page revision. So 1 page revision, classification is completely given on what basis they are classified into sp2, sp3, and what are the different varieties based on the number of halogen atoms, and based on the hybridization. Both the classifications I have given in this page. Gradually proceeding to further, I have gone to the preparations where you have your, you prepare your alkyl halides from alcohols. You'll be using concept of halogenation for this. You'll be also using or alkenes to get your final product. Correct? So the complete the preparations, whatever are there in 2 or 3 pages of your NCRT. So those 2 or 3 pages of NCRT is covered under 1 page. 2 or 3 pages put together is covered under 1 page. This is called 1 page revision. Okay. So 1 page revisions. This is done with the preparations. I already did one shot videos for this. So please watch one shot for detailed understanding. All right. Next, after preparations, gradually I'm going into physical properties. So physical properties, as I said, I have divided into both the solubility, basically for your aryl compounds. This is for the haloarenes, and this is for the haloalkanes. So here I'll be taking the haloarenes on this part, I'll be taking the haloalkanes on this part. Both are there on either sides. In this I picked up the concept of solubility, density, stability, dipole moment, melting and boiling point. On either side, this is a concept. All right. So the complete with the concept as well as a trend also is given. This is also called 1 page revision for your properties. 1 page revision. This is done, students, completely. Now let's go gradually after the classification and preparations and properties. We are going to go into the nucleophilic substitution. You have both the things, right? You have SN1 and SN2. So both the mechanisms, the order of this one, where you're seeing inversion, where there is racemic mixture, everything I have listed out in this particular section. So the complete, you'll be getting, they have 5 mechanisms, organic mechanisms, 5 organic mechanisms you have for your board examinations. So in the 5 organic mechanisms, these 2 are important part. Yes, right. Note the mechanisms. As I said, here you're going, inversion is observed, racemization is observed. I have bifurcated both together so that's easy for you all. All right. From there, gradually proceeding into the chemical properties of the haloalkenes, it shows 3 varieties of chemical properties. One is your nucleophilic substitution. All are listed out here. One is elimination reaction, where we are using aqueous KOH and alcoholic, where alcoholic KOH is giving us alkenes. So I've given the shades of rule also here, where you'll be getting sets of rule where the reaction happens in the presence of alcoholic KOH. So both are given here. Then comes your reaction with metals. In this metals, both what are the products formed? This is a general reaction. This is a specific reaction. So all the chemical properties, again, one page revision. One page revision is done. One page revision. This one page revision is also, it includes complete chemical properties, which is of 2 to 4 pages in your NCRT. Okay, 4 to 4 pages in NCRT is put into one sheet. Done. After that, gradually I'm going to the chemical properties of HaloArenes, where it's going to show ESR, electrophilic substitution. So I picked up one, this is called halogenation, 2, nitration, 3, sulfonation, 4, Friedel-Crafts alkylation, 5, Friedel-Crafts acylation, which is a major product also I have shown, and also I have mentioned why para is preferred as a major product. Right, students? Now gradually going into important sheet, very important sheet. All the name reactions of your haloalkanes, everything put together, I have given in one page revision. One page revision. So everything is done in one page revision. How many name reactions? 1, 2, 3, 4, 5, 6 you have for arenes. 1, 2, 3, 4, 5, 6, 7 you have for your haloalkanes. Isomerization is not a name reaction. Basically, it's a property of showing a change in different positions. Okay, just as the name remembers, I have mentioned it here. So completely one page revision of the name reactions is mentioned. Done, students? Done. So with this, I'm done with your one page revision. Now I'm going to discuss in detail the 1 mark questions. Let's see. This is basically what is the use of this, because your writing skills, your board examination expects your writing skills, right? So board exam or answer writing skills is what this particular series trains you. Answer writing skills. Suppose if this question is given for 1 mark, what should you write? Don't sit and write a big paragraph which will confuse the examiner. Simple. One, what are, there's a space here. What are ambidentate nucleophiles? Ambidentate nucleophiles. Simple. Directly write it to the point. Okay. First, start with this word. What is this? Nucleophiles. Because they're talking about nucleophiles, start with nucleophiles. What do these nucleophiles do? The nucleophiles can attack, or which attack? Which attack? Which attack through two different sites, which attack through two different sites. Why did I write this? Because in the exam I have seen when I go for board correction, students will be writing big answers. No, not required. Nucleophiles which attack through two different sites are called ambidentate. End your answer with ambidentate like this. Ambident or ambidentate nucleophiles. So when you write this complete, it's over. They've asked you for examples. So examples, you can write how many, this is a 1 mark question, right? So 1 mark question, what can you do? You can just simply give one example. That's enough, because half mark. So cyanide Cn minus. So what is a nucleophile? How is it attacking? N and minus. So this is the nucleophilic attack. So ambidentate. It can attack from here, Cn minus, or it can attack from your I should not write 3 because 2 bonds. It can attack from this part, from this here also and this also. Cyanide ion or isocyanide ion, Nc or Cn, correct? No, so Nc or Cn, this is the thing, you see. Okay, it can attack from carbon, it can attack from nitrogen. Let us see which is a better nucleophile, a bromide or iodide ion. Simple, they're giving bromide, they've given iodide. I have to write simple, only one word, don't elaborate it. Iodide. What is the reason? Iodide, you write full form. Iodide is a better nucleophile. Don't make it more lengthy. Why? Because you'll not get time. So why reason? You'll put it like this. You'll put it like this. Put a reason and write because of lower electronegativity. Point number 1. Write it fully. I'm not writing completely. And larger size. That's all. Nothing else is required for you all to give the examiner. He will only understand. Don't explain. This is only 1 mark. Correct? Simple. Right. Now next question. Arrange the compounds of each set in order of reactivity towards SN2 and SN2 displacement. So there are 3 examples given to me. SN2. First of all, SN2, what is the order? Write down. SN2 order is 1 degree, greater than 2, greater than 3. This is the concept, right? Okay. Now you only tell me all are almost similar. First of all, SN2 reactions depend upon what? Steric hindrance. So they will, the concept of SN2 only means it'll not prefer the compound which is more sterically hindered, which is less it'll prefer. So that's why 1 is more preferred than 3. Now among all these, which is primary students, easy, easy. This is your 1 degree, correct? Then which is your 2 degree? This is your 2 degree. This is your 3 degree. So the order is, you'll write completely in the exam. It is, you should write like this: 1 bromo pentane is greater than 2 bromo pentane is greater than, I'm writing down 2 bromo. Write completely, please. If you write completely, you'll get marks. 2 bromo 2 methyl butane, 2 bromo 2 methyl butane. This is okay. Okay, so the reason you write here, less steric hindrance, and finish off your answer. Easy, easy. Chalo. Next question. Arrange the following compounds in increasing order of boiling point. Don't again panic. Easy. When they've asked me boiling point, first of all, you write in the exam boiling point. So boiling point depends upon what? Write the concept. Here you write like this: concept. What is the concept? Boiling point increases as branching decreases. Is this right, students? Yes, right. Now this is the concept. Now let us write the order. For this you'll get half mark. For this you'll get half mark. Okay, now check which one is more branching. See here, they asked you to arrange in the increasing order of the boiling point, which will have more. So if the branching is decreasing, boiling point is more. Got it, students? If the branching is decreasing, the boiling point will be more. So I have to write the one which is having the least boiling point at the end. Okay. Now among all these, which one has more branching? This one has more branching. Okay. CH3 taken thrice. Okay. I said no, more branching. Okay. You tell me more branching. What is the other thing? Surface area. Okay. So more branching, less boiling point. Opposite, more branching, less BP. This is less than the second one, CH3, this one. Taken twice, CH2Br. Then third one, CH3, CH2, CH2, CH2Br. Did I write correct? 1, 2, 3, 4. 1, 2, 3, 4. Is it? Now see here, this is less branching. So what will happen to the boiling point? More BP. That's all. Easy question. Easy peasy? Yes. Next question. Define optical activity. Okay. Optical activity, 1 mark question. How should I write? Let us start the answer. I have to write the answer as compounds. Okay. Compounds only rotate, right? Now, what do they do? Compounds which rotate. So the word rotate, you need to underline. Which will they rotate? Rotate the plane polarized light. What will they rotate? They rotate the plane polarized light. How do they rotate? When it is passed through their solutions. When it is passed through their solutions are called optically active compounds, and the property is called optical activity. So you're going to write the answer, complete the answer with this, because they've asked me optical activity and property is called optical activity. Okay, easy, easy. Let us see one more question. Easy question. What is racemic mixture, racemic modification? Okay, so answer to the point. Don't elaborate it. Simple. They started with mixture, so you're going to also start with mixture. Racemic mixture is a mixture. Okay, mixture. What does it contain? Containing two enantiomers. In what? Any ratio? No. In equal proportions. Two enantiomers in equal PRO proportions. Will have, what will they have when they have equal enantiomers, plus and minus both? Then equal proportions, when they have, it will get cancelled, right? Will have zero optical rotation. We'll have zero optical rotation. Okay, optical rotation done. Now, as a rotation is due to one isomer will be cancelled by the other because both have equal proportions, no? Yes. Such mixture is called racemic mixture. So we mentioned it as like this, right? DL and isomer. Okay, right? Such a mixture is known as racemic mixture or racemic modification. Is it okay, students? So you're going to explain this in box. You're going to write that they have two enantiomers, underline this. They will have zero optical rotation. Write this. By this, the examiner will understand that you know the concept. Okay. Chal. Next question. What are enantiomers now? Enantiomers, simple. First of all, when such question is asked, use an example. It will be more effective. First of all, enantiomers are what, students? They are stereoisomers. Yes, now. So these, what do they do? When basically when we pick up a particular concept, when we try to talk or when we discuss about a particular concept of anything, so you need to have clarity of what you are talking about. Okay. So here specific keywords. So this is a keyword which you're going to talk. Stereoisomers related to each other. Okay, they are both related to each other. Okay, this is one. An important thing is, as they say enantiomers, each other as non superimposable mirror images, as non superimposable mirror images. This is what is a concept. So are called enantiomers. And your answer is as called are called enantiomers. So why am I writing this? Because when we write this, we know the sentence formation also. Let us take one example of this. So here, see here. One compound is having one group as CH3. One more is having as C2H5. One more is having as CH. Okay. And one is having OH. They have mirror images like this. Mirror images. So how does it look? OH and OH is here. One is CH3. Okay. One is C2H5. One is H. So this is an enantiomer, which are non-superimposable in each other. Done? Okay. Name the compound formed when name the compound form. 1 second, students. 1 second, please. I'll just pause it for a minute, please. Yes, sorry for the inconvenience. Okay, I'm back. All right. Sorry for the inconvenience. Now let's read this question. Name the compound formed when Grignard reagent is exposed to moisture. Okay. Grignard reagent. What is Grignard reagent? Okay. What is moisture? Nothing but water. What will happen, students? Simple. See here. One. Ta-da. Yes, easy. It's going to form hydrocarbon and MgOH excess out. So they ask what can name the compound. So you'll just write the compound is alkane only. Then they will not ask reaction. What is a compound? They ask. Compound is alkane. Answer is simple. That's all. Answer is just an alkane. Nothing to modify, nothing to expand, nothing. Simple, simple. Let's see one more question. Write the IUPAC name of this compound. Okay. IUPAC. How should I start numbering it? I have to start numbering from this part. Correct, na? So number this is 1. Then number this is 2. All right. And these two are branches. So can we expand this? This is like this. This is CH3. This is one more CH3. This is one more CH3. This is CH2. This is Cl. Okay. Now write down. So it is 1 chloro. Okay. This is the second carbon. So hyphen 2 comma 2 dimethyl. Dimethyl. What is this? Propane. Because how many carbons are there? See here. This is 3 carbon chain, right? Yes. I have done IUPAC nomenclature for many. Please watch it. Okay. Which of the following undergoes SN1 faster? 2 chlorobutane or 1 chloro? SN1 means less steric hindrance. Remember, SN1 means less steric hindrance. Okay. So, oh no. If I have to tell you, order shall we write, students? Order shall the trend is exactly the reverse of the trend. No, okay. The rates, first of all, let us see more, which is more bulky, or we'll say. Now, which of the following undergoes SN1 faster? Now in SN, what is the order, students? In the earlier question we have done 1 degree, 2 degree, 2, 3 degree. Shall we go back and see where is SN1 for us? SN2 this is. SN2 is preferring less steric hindrance. SN1 will prefer what is order? Tertiary, greater than secondary, greater than primary, very much greater than methyl group. Correct. Now which is in this case, okay, this is primary. If I have to take 2 chlorobutane, this is secondary, if I have to say. Now which is preferred, student? They ask which of the following, only one example I have to write. So this is 2 chlorobutane. Shall we see if this is whether it is secondary or not? 1 2 3, okay, 4. This is your chlorine, this is your CH3, this is your CH3, this is your CH2, this is your H. Isn't it secondary? Yes, it is secondary. Done. Next question. Which of the following, what is the order? Arrange the following compounds in the order of increasing boiling point. Okay. Boiling point. Just now I said, yes, boiling point are inversely related to a branching. So based on that concept, bromoform. Okay, first of chloromethane, bromoform. Okay, let's see. First one, subse come third, 3, then 1. Why? Because the molecular weight of chlorine and bromine. Bromine is more, right? Okay, then 4, then 2. That's the order. Okay, yes. So write the product form when toluene is chlorinated with the presence of sunlight. Simple questions with 1 mark. See here. This is toluene, right? So what are you doing? You're chlorinating it. Okay, done. And then what you're doing? You're applying sunlight. Easy free radical halogenation. Yes, one H comes out as HCl. And what is the left out one? And the left out one is CH2Cl. What is this called? Benzyl chloride. Correct? Na? This is called benzyl chloride. Easy? Very easy. And gradually one more question. Right? Make the product form when N-butyl chloride is treated with alcoholic KOH. Okay, N-butyl chloride is treated with alcoholic. We very well know. Where do we use this alcoholic KOH? We have used for elimination reaction. Correct? Na? Elimination reaction, and it follows which rule? Sage-Zeph rule. Correct? So take out the equation N-butyl chloride 1, 2, 3, and 4. This is CH3, this is CH2, this is CH2, this is CH2. This is what, students? This is N-butyl chloride. Now what are you treating with? You're treating this with alcoholic KOH. Alcoholic KOH. What will happen? It's going to undergo elimination reaction. First you pull out the KCl, you pull out water, and which product? One product, one ene is more stable, which forms a major. Correct? CH3, so CH2, 3H, and double bond. So one butyl chloride will form but1ene. Concept also I have explained Sage-Zeph rule. You can watch the video. I've clearly explained the concept. Done, students. Now next question. Which has higher dipole moment, chlorobenzene or cyclochlorobenzene? Okay, let us draw first chlorobenzene structure. Okay, I am drawing chlorobenzene structure with the pi bonds. Okay, this chlorobenzene structure, cyclohexyl chloride. Okay, let me draw the structure of this. I'm drawing chlorine here. Now you tell me this carbon, whatever where your chlorine is attached, it is a double bond. Correct? Na? Alright. This is more electronegative, it will drag. This will become electropositive. Now what is the hybridization here? This is sp2 hybridization. Now again, chlorine is going to drag. This part will become positive. What is that? There's no bond. There's no pi bond here. Correct? So the hybridization is sp3. Now you only tell me here in which one more S character is there. Yes, sp2 has, this has more S character. Okay, more S character. Okay. And the carbon is here, it is more S character, and carbon is more electronegative also in this case compared to this. Okay. Now here in sp2 the CCl bond has less tendency because more X character means more pull, no? More pull. So what will happen? Less tendency to release electrons. Am I right? Okay. When it is less tendency to release electrons, what will happen? this bond, CCl bond in chlorobenzene is less polar because it will not release, no, because it is tightly held, less polar. In other words, whatever negative charge is there on Cl, no, on chlorine, the magnitude of negative charge on chlorine is less, right? On this, okay, magnitude, because there's no, it's not releasing it. Magnitude of negative charge is less on chlorine. Correct, right, students? Okay. Now, you only tell me this in this case more. There's again delocalization of electrons also. Delocalizations of electrons also. So now you only tell me which one will have more dipole moment, which will pull. You mentioned I have given all the parameters here. Can you tell me which is having more pull? What is where it is dragging? Can you tell me the answer? Which one? Answer in comment section. And I'll be waiting for the comment section. The student who is going to answer it correct, your answer will be pinned. Pinned means it will be permanently there in the world of chemistry. Alright, answer that. Next question, students. How many chirals and chirality? How many chiral centers of chirality present in 3-bromopentane? Pent 1-ene. Let me draw the structure and see. Chirality means a carbon atom attached to 4 different groups. It will be A, B, C, and D. Let's see. 3-bromopentane. 1, 2, 3, 4, double bond C. Okay, this is hydrogen. This is also hydrogen. Okay, this is CH. I'll write hydrogens like this so that it is easy for you all. H, and this is H. And to this carbon, 1 and 2. Okay, this is then here hydrogen, students, because already 2 bonds are there. Third one to this carbon, they say 3 bromo na? 1, and this is H. Okay, now this is 3 bromo. Now check this carbon. This carbon, I'm going to put a star. Let's check. To this carbon, one CH group is different. Okay, done. To this carbon, bromine is one more. To this carbon, CH2 is one more. To this carbon, H. Yes. So how many chiral centers does it have? It has only one chiral center. Why? For this group, because bromine is the only different group here. Because here if I see 2 hydrogens, here if I see 2 hydrogens, here if I see 2 hydrogens. So bromine is a different group. That's why only one chiral center. Got it, students? Chiral center. Easy. Next question. 2 marks questions. Okay, 1 mark or over, 2 marks. Write a short note on Sandmeyer's reaction. Okay, nothing from Sandmeyer's. How do you write? Because it is 2 marks, I should be clear. So let us write the answer. Okay. Sandmeyer's is diazonium salts. Start like this. Diazonium salts when treated with cuprous chloride or cuprous bromide or cuprous cyanide, such reaction is called Sandmeyer's reaction. This is okay. Such reaction is called Sandmeyer's reaction. This is the definition of it. Now let us write the reaction. You'll write your N2Cl. Okay, B N2Cl. Now in this N2Cl, what you're adding? It can be treated with your CuCl. It can be treated with your CuBr. It can be treated with your CuCN, as I've said. Everywhere, whatever you're getting, the products can be the nitrogen gas eliminated. Okay. Now, what compound? Either you may get chlorine compound, or you may get bromine, or you may get cyano. Easy. But here, important thing is, what is the mechanism? The mechanism which Sandmeyer's follows is free radical mechanism. It follows free radical mechanism. Remember that. It follows free radical mechanism. And cuprous halides. What is the role of the cuprous halides? The cuprous halides act as catalyst. They act as catalyst. So when you write all this information, the examiner will he'll say, wow, this child knows everything. He'll give you full marks. Okay. So this acts as a catalyst, and it will provide what does it do? What is its role? It's going to provide phenyl free radical. This is what is important. It provides us phenyl free radical. This is the reason Saint-Mayor's reaction, when they ask you, the complete answer is here. Got it, students? All right. Chalo, let us see the next question. Write the structures of the main products. Chlorination of benzene in the presence of UV light. Okay, simple. Let me write. I'm taking benzene. Okay. What am I doing? I'm doing chlorination to this. In the presence of what? UV light is what is a condition given to me. Okay. So three chlorine atoms. So UV light, what will happen, students? UV light simple. The fastest, the reactions are fast, right? So all the bonds are broken and you be getting without any pi bond, all the bonds are attached by chlorine. So C6H6 Cl6. Is it? Yes, easy. Let us see the next question. Let us see. Now three chlorine atoms. Yes, 3 2 are 6. Next question. Propene is treated with HBr in the presence of benzoyl peroxide. Whenever you see peroxide, what is the reaction? It is anti-mark addition. Correctness, students? Okay. Let us see propene itself. 1, 2, 3. They have not mentioned any number. So propene, either side it is the same, right? So this is your propene. Okay, this is your propene. What are you treating with? You're treating with HBr in the presence of what? In the presence of benzoyl peroxide. Write it on the arrow. Benzoyl peroxide. Anti-Markovnikov rule. What does it say? Yes, it forms, or the negative addendum goes and adds to the carbon having more number of hydrogens. So this goes and adds to this carbon, breaking this bond. So CH3 CH2, CH2, Br. So it is 1 bromo propane. Correct, na? Okay, easy. Next question. Complete the following reactions. Simple questions, students. Nothing, there's nothing. This is BDC. Once I get BDC, nothing I remember. Only thing I have to do is I'll write here nitrogen gas will escape out. KCl salt will escape out. That's for sure. Now, what is left out? The left out iodine will go and attack this. C6H5. This is the only thing. Next, CCl for carbon tetrachloride, you're adding bromine. Okay, so double bond breaks. One bromine goes and adds here, and one more bromine goes and adds here. What do you get? CH2Br and CH2Br. That's it. So you can completely write like this also. Instead of writing this bond, you can write like this also. CH2Br, CH2Br. That's it. Same thing I have written instead of size. Easy, easy question. Next question. Write short note on Wood's reaction, Wood's fatigue reaction. Okay, so both the name reactions in the first one page revision where I have written one page revision just initially in the starting of the video, one page revision, all name reactions in this video only. I have written name reactions. I have written the reaction. So please watch that. Okay, next question. How will you convert the following? Oh, easy. Very easy, students. Conversions, I'll be doing a video also very soon. How will you convert the following? Chloride to alcohol. Okay. As I said, whenever you see this alcohol, no, remember, simple. Use aqueous KOH. Aqueous KOH. Easy. See here. Your C2H5Cl is there. Correct. You're going to use aqueous KOH because this OH is there. No, it will go. If it is alcoholic KOH, you'll get alkene. But here, aqueous KOH, your OH replaces this part and your KCl is out of the reaction. So, ethyl chloride to ethanol. That's all. Easy. This is the first part. Will you do a second page? No. I'll use this page only. This is for the first reaction. Ethyl chloride to ethane. Okay. So, see here. What is, first we'll write ethyl chloride. Now tell me, student, ethyl chloride. Let us write ethane, C2H6. Now you only tell me, compared to this one and this one, which is less in this chloride is coming out. What is chloride? It is an electronegative atom. Removal of electronegative atom is nothing but reduction. Correct? Na? You're going to remove the electronegative atom. Reduction. Reduction is nothing but addition of hydrogen. When you remove, I have to remove this and I have to get that. I have to add this to this so that I get H6. I should also remove. So I'll take 2 moles of this. So this is HCl. Done. Simple conversions. Only logic is you have to remember the concept. Is it, students? Yes. Next question. Alkyl halides are insoluble in water though they contain CX bond. Okay, why they are insoluble? Two keywords are there in this. Okay, so haloalkanes. First of all, write down haloalkanes cannot form hydrogen bonds. Cannot form hydrogen bond. Point number one. The examiner will say, wow, this is right. With which one? With water molecule. They cannot form a hydrogen bond with water molecules. Okay. And at the same time, and at the same time, cannot break the hydrogen bonds present in water molecule. So both, because it requires more amount of energy. Yes, that's it. That's why they are insoluble in water. They cannot form, neither cannot break. So you will underline this word in the exam. Cannot break the hydrogen bond. You will underline this. Simple? Simple. Next question. Give one test to distinguish between chloroform and carbon tetrachloride. Okay. So first of all, students, chloroform and carbon tetrachloride, simple. Chloroform, when I see what test you remember? Yes, isocyanide test. Isocyanide test. Correct, na? Isocyanide test. Now let us write. First of all, I'll take aniline. This is here. Then I take chloroform. I add alcoholic KOH to this. Alcoholic. And I heat it. What will happen, students? You'll be getting an offensive smell compound plus KCl plus water. Am I right? Yes. So if I balance this, this is 3 KCl, and when I balance this, this is 3 KOH. Now tell me, chloroform when heated forms this. Does carbon tetrachloride shows this? No. So chloroform shows isocyanide test, but CCl4 does not. That's an easy. Do I have one more? One more. Give one test to distinguish between methanol and ethanol. Okay. Easy. Simple question, students. Nothing. See, you are saying meat. Remember, methanol gives iodoform test. So one test which can differentiate is methyl ketones or methanol iodoform test. Iodoform test, what happens? You take an alcohol. Okay. Then you add iodo and sodium NaOI along with iodine. What do you get? Iodoform precipitates out with the byproducts which are there. Plus, I forgot to tell you, I have done a video with this iodoform. Watch it, students. It's a wonderful video. At the same time, when I take ethanol, or this is ethanol. When I take methanol, okay, I'm sorry, I should not say ethanol. When you take ethanol, this shows iodoform test, not methanol. So when I take methanol, when I add, I'm sorry for that, NaOI, and I'm adding NaOH plus iodine. Here, what is this color? This is an yellow PPT formation. What is this color? There is no yellow PPT. There is no yellow PPT. So you can tell that there is no yellow PPT. So ethanol responds to iodoform test and methanol does not. That's a differentiation test. Next, write the short note on Finkelstein and Hunziker. As I said, students, in one page revisions, I have done the name reactions. Just now I have shown one page revisions, name reactions I have done in the starting of the video, the initial part of the video, So please watch that initial part of the video so that it's easy for you. Then next question. That's it? Yes, that's it. So these are some more 1 mark and 2 mark questions, students, including that all the answer writing skills I have given. Here further I have given you some more questions like the question and the answer. So it's easy. You can directly write this answer in the exam. And some more questions for you all. Explain why vinyl chloride is unreactive. This question also. Explanation is given. One more question, very important question, students. This is a very important question. Note it little bit because when I was converting, it got a little bit much. Students, this comes here, this comes here. I'm sorry for that. Okay, yes, students. All right. Okay, no, this comes here, this comes here. Let me erase and show you so that it is easy for you to take it. Okay, I'll to show you which one comes where. This chloride comes here. Okay, this one comes here. Okay, this one, I think this part, this part, okay, this part has to come here. That's sorry for that. Okay, children, next question, students. Are you BSc? Simple, some more simple questions which I have added. Okay, all right, you can note this. Some more questions you can add, some more, few more questions you can add and study directly. Few more questions. That's it. So that's it for today, students. These are today we have discussed one page revisions. We have discussed 1 mark question and answers. We have discussed 2 mark question and answers. Correct na? So tomorrow I'll be meeting you with 3 and 5 marks questions. Then we will do assertion, reasoning, everything. Alright. So thank you for watching. Goodbye. Signing off. One request, students. One request is please share the video. One request. Please like the video. Please share the video. We are using our voices. We are using our throat to teach you all. Please share the video. Like the video. Thank you.